the course web page. So that is already available with you. So please start with the part B and start pasting answers on that. So all of you, please start solving part 3B. So the problem is defined as given two ordered sets x and y of integers. Let us solve the first problem of their union. So I would now like to find an ordered set of integers, which is the union of the two sets. And the first thing is to write a recursive definition. So can anybody define the problem verbally? Can anybody speak out? What is the input? What is the output? And what am I expected? What is going to return?
Like input will be x and 1, the output will be
Z.
next.
And Z will also be an ordered set without duplicates. It will be the union of
X and 1.
x and y. We also want to find intersection and set difference. We'll do that after we find the union. So please do the solution and at least do the first recursive, generalized recursive solution. How would you do the generalized recursive solution? Or if you have any other method also, which is good, I would like to see you solve it part by part and share. Can anybody write down any recursive algorithm?
So we could go about by finding out finding out where first finding out the middle element of x, searching for where it should be placed in y, and then dividing it into two parts and searching it correspondingly. But so I haven't written the function yet, so
Write down something. Writing down is important. Thinking is important.
Sir, I think I have some way of doing it.
हाँ बताओ ना.
Sir, if we define a function which takes in the z, x, and y, and it will modify the z and return it. So, so two base conditions are there. If x equal to null, then return y, and if y is equal to null, then return x.
Correct. Very good. Wait, let me share the screen and start writing what you are doing, what you are saying, huh?
Yes, sir.
Or you also start writing and tell us.
I have written it somewhere.
You pasted it.
What, sir? No,
Have
sir.
you pasted? No. Wait, let us do it step by step. I'll ask all of you one by one. Let us see what happens. So can you all see the screen? Can
Yes,
you all
sir.
see the screen?
Yes, sir.
Okay. So my output is Z is equal to union of X and Y, right? Where X is equal to this is what you said, na? Druhin?
Yes, sir.
So what are your base conditions?
If x is null, then return y.
Okay. If X equal to null, Z equal to Y. If Y equal to null, Z equal to X. Correct?
Yes, sir.
Now I'm asking, can anybody tell me a recursive condition now here? Can anybody tell me the recursive condition? Any one way. Ishan got one way, but can anybody tell me any other way? Any way. Alapan?
Sir, since it is sorted, both the sets are sorted, so we can start by comparing the first element of x1 and y1.
Correct.
If x1 is smaller, then we will subtract, we will remove it from x and then put it in z.
Wait. Let's do this. Now we know that both of them are not null and one of them is not null at least. So both of them have some element. Is that what you're saying, Rajdeep?
Yes, sir.
So now you say if x1 is greater than equal to y1, then what will you do?
We will put it in z and then subtract it from x.
Recursively.
Then we will subtract it from x list.
So if x is, so you'll take out this from x, right? So you'll write x dashed is equal to x minus
x1.
Then what will you do?
Sir,
Anybody
then
else? Wait. You keep quiet. Somebody else tell me. What will I do next?
So call the function on x dash and y.
Very good. Who said this?
Apurva.
Very good. Very good. So I will get z dashed equal to union. Tell me x dashed y. Then
So z equal to z dash plus x1
z equal to x1
plus
followed by
z.
z dash. Here it is not union, it is ordered union, right? So you are going to concatenate it. You are going to put x dash in the beginning of the list, right? X1 you are going
Yes,
to put
sir.
in the
Yes,
beginning of the list, right?
yes, sir.
Sir,
Hmm.
sir, like if the first element of x is already greater than first element of y, means x1 greater than y1, then I don't think there is any possibility of finding y1 in x. So we can also remove y1 from y or not.
But you don't know if the next element, if x2 is greater than y1 or not, you don't know, na? Abhishek?
Yes, sir. Yes.
Got it?
Yes, sir.
So that is why you have to do the recursion.
Sir, but for x is an ordered list. So if x
And y is also an ordered list.
yes, sir. So if x1 is greater than y1, then x2 will definitely be greater than y1.
How do we know? They are not ordered that way. Then we have no problem to solve. But there is still a mistake in what I have written. So correct it.
Sir,
There
can
are
you?
three cases.
Okay. Oh, okay.
One case, first case is this greater than equal to correct? I have to do
Should be greater
union,
than.
na?
Less
But
than.
it's
Should be greater than.
I think
It
it
should be
should
less than.
be less than.
Let us do one greater than, huh?
Okay.
If x1 is greater than, okay. Now there can be other case if x1 is equal to y1. Then what do you do?
So we subtract from both of
Yes,
these sets.
X dashed equal to x minus x1. Y dashed equal to, I'm writing in longhand just for everybody to understand, y minus y1 and recursively call
Union of
z
x
dashed on
y dash.
and return
Z equals to x 1 and z prime.
and what else? What is the else part that is left?
Equality.
Else part will be what? Now y1 is greater than x1.
Subtract from y and
So y dashed is equal to
y minus
y
y
minus
y1.
z dashed is equal to Abhyuday Agarwal. Tell me what to do. Abhyuday. What should I do?
Hello, sir.
What should I do? What should I do? Are you following or watching a movie?
Yes,
Arup
I am
Baral?
following.
Arup Baral, but you're not answering my question.
Sir, x and y dash, union of x and y dash, and then we will concatenate y dash, y1 to z dash.
Very good. Then z is equal to y1
Ordered union of y z. Yeah.
and finally return z. Is this clear to everybody?
Sir,
Yes.
sir, I have a doubt with this greater than and less than, sir. Like like if x1 is greater than y1, then means if we're why are we not doing y? Means y dash equal to that. Y dash equal to y1 if like subtracted.
But y1 may be less than x2, na? Y1 may be greater than x2. Y1 may be less than x2. I don't know. See,
Sir, first we have to consider which order is in it, like ascending or descending order.
It is in descending order.
Oh, okay. Okay, so then it's fine.
I'm sorry, I should have told the order ahead.
Can we do order also?
Huh?
So can we do in ascending order also?
Obviously, you just have to change. You just have to change which one to remove. Right? You have to change which one to remove. If you want to do in ascending order, then if x1 is greater than y1, you remove y1. Equality part remains same, but the first part and the last part changes. Which one you remove? That is all. Is it now clear to everybody that it is in descending order?
Yes, sir. Yes, sir. Got it.
Yes, sir.
So now if I have to do this, then what is the complexity? How do I define complexity? Can anybody tell me?
No, sir, it will be the sum of the elements in X.
No, write
plus...
the recursive equation.
Okay,
En is equal to.
So we would have to take Tn, comma m.
It would be Tn, m, na sir?
हाँ Tn, m ही ले लो. ठीक है. Let me erase this and write Tn, m. But here it is easier. It is easier to do Tn. It's not a problem. Because I am removing one element at a time, na? Where n yes, is equal to
Tn minus 1 plus 1.
and you have your base conditions that if any one of them. So as somebody said, you can also write it down like this. You can also write it down like this. You can also write it down in another way. You can write T and M is equal to 0 if n equal to 0 or m equal to 0, isn't it?
Yes, sir.
And it is equal to what else? It will be T either Tn minus 1m plus how many comparisons you require?
2.
2. If so, either this or Tnm minus 1 plus 2, isn't it?
Yes, sir.
That is why I wrote this. Because I took into account this one and I wrote this. Arya Rajendra, clear?
So
Yes,
I don't
sir.
understand what are the two comparisons?
One is equality, one is less than greater than.
Okay.
Order 1. Two comparison is order 1. Avais Akhtar, is it clear to you?
Yes, sir.
So what is the solution to this recurrence? What is the complexity of this algorithm?
Order n.
Order n, sir.
Perfect. This is an order n algorithm, where n is equal to the size of m plus n, so size of x plus y. Who has not understood? Who would like to suggest any better solution?
Sir, I have something in my mind, like in recursive definition, first we choose any, let's say, random kth number, let's say, from x, and then we initiate a for loop to find the smallest greater number from that U1. Then you can split that number in.
Correct, correct. Like what Ishan was saying. What Ishan was saying.
Yeah.
What Ishan was saying was like this. What Ishan was saying was like this. That you have got X and they are ordered. And because they are ordered, you will choose which element, an arbitrary element from here, from Y, isn't it?
Anyone like X.
Choose some Xi, find its position K in Y. That's what you're saying, right?
Yes, sir.
Whether it exists or it does not exist where it would have existed. What method would you use to do this?
So binary search.
Binary search.
And once you find its position in Y, then Y splits up into two parts, Y1 and Y2. And if you have chosen this X, then based on Xi, then X splits up into X1 and X2. Correct?
Yes, sir.
Now what to do?
We will call the union on a y1 x1 and y2 x2.
Now tell me, if you do this, will it work? So you will now do a union of X1, Y1 to get Z1. You will do a union of X2, Y2 to get Z2. And then you'll just join X1, Z1 and Z2 and put in Xi in between. Correct?
Yes, sir.
Yes.
We will put in xi if we couldn't find xi in y.
If you found it, you would have removed it from both.
Yes.
And if you didn't find it, you will remove it from one of them. If you found Xi in Y, then you remove it from Y. Otherwise, you remove it from X, and finally Z is equal to Z1 followed by Xi followed by Z2. Is that what you are saying? All of you who are trying to develop this algorithm.
Sir, I have tried writing it down and sent it in the chat.
Yeah, I'll check. But I don't. Did you get it? Yeah. You wrote it in the chat. Correct. So now compute the complexity of this. Has everybody understood this? Very good, Rudajyoti, very good. Has everybody understood this? Balshankar? Sumedh, Kishore?
Yes, I understand.
Now analyze this. Charvi Jain, have you understood? Bhushan Nakade?
Yes, sir.
Bhushan, tell me if you have understood both the methods. Have you understood both the methods? Bhushan?
Not clearly. Not clearly, sir.
Which one did you not understand?
The second one.
The second one, he says, if I have got x1, you understood the first one clearly, though?
So not though clearly because my some concepts are not clear. Like I was not able to attend the last class.
Okay. Arunava Sarkar?
Yes, sir.
Have you understood both the methods?
Yes, sir, I have.
So can you tell me, is one method always better than the other?
Sir, I think the first method would be better.
The first method would be better?
Yeah.
Anybody would like to contest?
So I think the complexity of the second method is big theta LGN.
Only LGN. By LGN, LGN will be required only for the binary search.
So, but
sir, it would be n log n, because for like binary search, we have to go through, I think, n elements.
Correct. So, what would the equation be? Aribaba, tell me the equation. Your
Tm comma n equals to
Tn is equal to, let us say, in the best case, it will be broken down into two half size, na?
Half.
Yes.
Plus
O log n plus log n.
Yeah, or log n. What would this give by master theorem? What would this give? If you break it up, if you guarantee to break it up in the middle all the time, if the element so chosen from xi, this is the best case. Then
so log 2 and log n squared.
Square.
निकालो आप लोग log n squared हो जाएगा. And
So
what is the worst case?
So,
what is the worst case? The binary search will tell you
the last element.
The first element or the last element, है ना?
Yes.
So then it will become like this, no?
Yes, sir.
Very good. Who said this? Who said this part? I forgot to see, I was writing. Who mentioned that this is the worst case? अरे भाई बोलो ना. Silence. Aman Kedia? Aman Kedia, are you there?
Yes, sir.
Are you okay with this worst case definition?
Yes, sir.
So now tell me, is this method the second method of any use? Or the first method is always better than the second, or what?
So I think the first method will be always better. So because in second case, yeah, that is not like. In the first, we are going one element like one by one, and then we are like taking the
Okay, anybody would like to contest him?
Sir, like T of n equals to, in the best case scenario, it will be order of n.
This is order of n, no?
I think so.
But tell me, so the other one is anyway order of n. And this one's best case is order n, worst case is order log n. Is this best case order n? This question. Can you tell me, and can anybody tell me a case for bonus marks when the second one will be better than the first one?
So when the two sets are completely disjoint and the last element of X is lesser than the first element of Y.
Good. Any other simple case?
Sir, if there is only one element in one of the list?
First class. If there's only one element in one of the list, very good. Sanket, nahi? Your name is?
Sanket, sir.
Sanket. Very good, Sanket. Has everybody understood that if one of the elements, if Y contains only one element, what will be the second method doing?
So can you repeat the question?
The question is there a case when the second method is better than the first?
And just join x1 and y1.
Sanket said that the second method is better than the first when set X is large and Y has only one element. Is it now clear? Is that what you said, Sanket?
Yes, sir. Because we are only doing binary search in that case, which takes log n.
That means if Y has, let us extend that, if Y has a constant number of elements, then also it is possible. Now the question comes, can you find the best of both worlds? Can you find the best of both worlds?
So like if we know the crossover point, then according to the size of the inputs, we can determine whether to use the first one or the second one.
How do we know the crossover point?
Like we need to find out the complexity of both of them. Like exact complexity, I think.
So when you have such things, then you take recourse to something else. You take recourse to what are called. So suppose I have an ordered list 5, 7, 12, 8, 18, 23, 86. Are you all with me?
Yes.
You
Yes,
remember
sir.
our tournament method? So actually this is represent, because it is sorted and binary search works, what is the conceptual data structure for this? Though you have written it in the format of an array, but because it is sorted and because you do binary search, can anybody tell me what is the conceptual data structure for it?
Binary search tree.
Perfect. The data structure is like this. Correct? This is how it is conceptualized. This is how the winners of the tournament proceed. Divyanshu said, are you with me? Sai Sarat, are you with us? Gunjika Dhanuka? Jogu Bhanuteja?
Yes, sir.
Are you clear now about this?
Yes, sir.
So now when you have two such, so these are binary search trees. When you have two such BSTs, we are talking about their union, intersection, set difference, etc. So now we have seen two algorithms, two approaches. And now when you see, if you have one like this, and suppose you have another as 8, 12, 16. So the binary search tree of this will be 12, 8, and 16. Now, if we use the second method, somebody was saying that I need to choose that particular element to join. So which are the two elements I will start choosing from here? Now?
So we start with 18 and
so now I'll leave it to you. I will not solve this problem anymore. But now you can find out the best of the two worlds and show that when there is fewer elements on one side, larger elements on the other side, what will you do? Which one will you choose? How will you guarantee that you are not doing more than order n, and yet when the elements are small, you are doing only enough? Because if you have to search an element in a binary search tree, how much time does it take?
log n.
Log n. But if you take each one of them like this and try to search there, you will reach m log n. But what would you like to do? You would first look at 12 and then put the whole of 12 and 8 to search to merge with the subtree 7, 5 and 12. Correct? And you would take 16 and merge with 18, 23, 20, 86. Or you would take 12, 8, 16, whatever you want to do. So I will leave it here. Do you know what is the famous name of this algorithm here, which we wrote as union? You have seen this algorithm before.
So merging part of merge
algorithm.
This is the merge of merge sort. And you can use the same thing to find intersection, hai na? Where will it change if you want to find intersection?
Sir, we will like modify the x1 equals to y1 part.
Only check equality, nothing else.
Yes, sir.
Equality or not equal. Finished. Okay, I think we've got an idea. Anybody has any doubt on this? Good. Palash, we can move on to the next question.
Sure, yeah. So please start solving question number 4 and paste your answers on chat box.
Sir, will it be theta of n?
Yes,
Yeah.
sir. Even
I
I
think,
got theta.
yeah, it is theta, but all the proof and paste in chatbox. Alapan Shen, if you write this sort of proof, you will get under in the exam.
Okay, sir, I understood that to prove.
How many parameters T takes? 2 parameters. Look at the right hand side.
No, sir, actually, if when t of, if we put t n
Whatever you
comma n,
write, you define it properly. Okay, so there is one more answer. Let me see.
So I have shared a solution.
Yes, Ishan's answer looks on the right track. Yeah, I'm not checking the calculation, but he's on the right track. Yeah, what is K? Ishan, what is K?
So K is the point at which the number falls below the threshold of 50.
Correct. Okay, so what is the value of K?
So I don't know the value of K because of the 50 threshold, but we know for sure that it will be finite because we're constantly dividing it. So maybe I'll try to compute it.
so will it be log 3 by 2n?
Yes, correct. It's roughly like log n, no? Base 3 by 2.
Yes, sir. But yes, sir. So maybe n minus 50 or something. I was thinking along those lines.
Okay.
So the k and for a half, it should be not k, but some different terms because n by 2 to the power something will reach 100 first. Means will reach 50 first before 2 by 3.
Yeah, it will not be exactly log of 3n, but
Yes,
some constant will be there.
Yeah, so it will go on till k steps, and then when n by 2 to the power k becomes lesser, at that point of time.
Yes, Ishan, you are right. So see, others is you see when the base condition. So there are two base conditions. Yes, it is. It only looks a little difficult because maybe of two parameters, but it is really easy. Okay. So anyone has any question on Ishan's answer? You can do it in any method. For example, you can try substitution method. You can try recursion tree. You can try this simple naive approach of expanding, unrolling. All methods are fine. Very easy. So if you have understood, if you have no question on Ishan's answer, then move on to question number 5.1.
So could you please show us how to solve it using substitution method?
No, I won't show you. Try. You haven't tried. For t n comma n, for example, you can try to prove that t n comma n is less than equal to 100. I don't think it will be difficult to prove. Have you tried? So for substitution method, you need to show two things. You need to show by induction that t n comma n is less than equal to say 100n, and t n comma n is greater than or equal to say n by 100. Then the first one will show t n comma n is big O of n. The second one will show t n comma n is omega, big omega of n. Together you will get t n comma n equal to theta n. You try, it's very easy. Okay. So yes, so you if you have, so you do not have any question on question number 4, can you move on to question number 5? 5D you try first. This will help you in your assignment. Others are routine. You try 5D first. Others are just for your practice. Yeah. It's like when you learn a plus b whole square, there are 50 problems. It's like a replacing with b, something like that. Do 5D. Yeah.
So is it O log n?
I don't know. You have to write. I've not done it. So write the complete proof on the chat box in the chat box. Vaibhav, because your second step is wrong. Okay.
Okay, sir, I'll check.
You have to answer in theta term. Kompella Lakshman Pradeep. If not big O. Yeah, it is right that it is, I think, yeah, it is big O of log squaring. But is it theta of log squaring? Read the question.
Yes, sir, theta of log.
Lakshman Pradeep Kashyap, are you saying anything?
It's theta of log and log.
But that's not clear, right, from your proof? Why it is theta of log squaring?
No, yes, sir.
Because it's not, everything is not like even the in the second line, the third term is wrong.
Yes, sir.
Yeah, correct it. Yeah. How many of you are reading any books except our slides? Yeah, just raise your hand. How many of you are reading any of the reference books sincerely, regularly? Let me reiterate that lectures are not at all sufficient. Ideally, you should try to read as many reference books as possible, at least one or two or three if you can. And all these problems, because these problems will be like laddu problems if you have read reference books. I have taught you main techniques for solving recurrence relations, but how to apply them, how to play with various things, it's like I teach you for a formula of integration or theory of integration, but if you don't practice integration from several books, solve problems, you won't learn. and the difficulty I can see, and this sort of difficulties is it's severe lack of reading reference books. You can just compare how you were reading during your preparation for IIT joint entrance. Just do 50% of that. Whatever things you used to do, just do 50%. For example, if you are reading 2 books for part subject, for mathematics 2 books, so you have for part subject you read 1 book. Per topic, if you are solving, I don't know, 50 questions, you solve 20 questions, that will be enough. You're not doing that also. And that's why all these difficulties.
Rajdeep, Ritik, you have anything to ask?
No, sir. No, sir.
No, sir.
Okay.
Arup Godal's solution looks correct to me. Just replace big O with big theta. That's enough.
Yes, sir. Yes, sir.
Just replace big O with big theta. That's enough. Yes. Alapans is a more standard method. It's like change of variable, but not n plus alpha. What do you not n plus alpha? Oh, for okay. You wrote n plus alpha for to get rid of flow. Yeah.
Yes, sir.
Yeah, okay. And then change of variable. But the from bottom third line.
Yes, I consider s of 2 to the power m minus 1 will be s of 2 to the power m.
Just write s prime. Just be formal, as if you are defining some s prime, and then it is fine. It's also correct. Yes, you can. Everyone can see 2 different answers: Arup Godal's and Alapan Sen's answer. Both looks correct to me.
So, I'm not very clear with the substitution method. I tried solving the sum with it. Could you please guide me? So I'm not very clear about my own steps.
So for substitution method, there are specific recurrences. If you read reference books, I won't say the name, but in few reference books, there are few references and few examples of recurrence relations where even if the answer is set Tn equal to big O of n, if you try to prove that Tn equal to less than equal to Cn and try to back calculate what will be the value of the constant C, you won't be able to find the constant C. And then the book itself talks talks about a trick how to use substitution methods in those sort of cases. Am I making sense, or let me repeat? So even if there is a given you a recurrence relation, and even if the answer is Tn equal to big O of n, it may be possible that there is no constant or such that using substitution method you can prove that Tn is less than equal to Cn. There is no constant C. But then what to do? Then what? How can? And that's so interesting. I'm just spiking your curiosity. We just go and find. In one of the reference books it has been discussed.
Okay.
Okay. So
in the solution that I have shared, are my steps correct, or?
I don't know what is K, because you are in the last answer you have unresolved K. You have not written K.
No,
And
sir. So actually,
yeah, keep thing. Where is the starting
so,
point? Less than equal to C1 log n.
Yes, sir. Yes, sir. So the first line came by mistake.
Okay. And then why is the substitution method? It is a proof by induction. I can't see any induction in your proof. Substitution method, you have to prove it by induction. I'm not getting how you are applying substitution method. I can't follow it. This is not the substitution method I have taught. Okay. So if you are happy with Alapan's answer and Adup's answer, then solve the last question. 5A, B, C, those are super easy. You do it yourself. Sixth question you solve.
So like any periodic function like trigonometric function, like tan x and some sin x.
Read that carefully. Read carefully. Read the question carefully. Have you understood why trigonometric function will not?
Is n to n.
N to n minus 0. Or what have you written? K belongs to where? I can't read it.
The whole number. K is a whole number.
Whole
I mean,
number
for one. Sir,
K is whole number means natural numbers.
it's a natural number.
1, 2, 3, 4, and those sort of things.
Yes, sir.
But both are.
I mean, if at means for one interval fx is greater than gx, while for other interval fx is less than gx.
Not less than, greater than. Both are big of theta of n, isn't it?
Yes,
X
yes,
is
sir.
theta of n, Gn is also theta of n.
Yes, sir. Yes, sir. Sorry.
Yeah. Yes, Ishan's answer looks correct to me. Anyone can find any bug? This looks correct to me. Good. Everyone can see Ishan's answer. Also, there is lots of answers. It is better not to see Ishan's answer or any answer. You just think. We have all cracked IIT JEE. It's very easy. But if you have seen Ishan's answer and if you if you find any problem, you just let me know. I can't see any problem. Okay. So any question? Question number 6. Approved Modak.
Yes, sir.
Have you understood?
Yes, sir. Yes, sir. Sir, you're not quite audible.
Your voice is breaking a little, Palash.
Maybe because of the new microphone. Hello.
Your voice is breaking a little. Your microphone has caught COVID.
No, so my old headset was bad, and there is a new microphone, but this is giving me some trouble. But is this better now?
Yeah, little bit of medication happened, but it is still COVID infected, it seems.
Okay. Okay, so yeah, if there is no more questions, so let's stop here. So we'll meet on Monday at 12 p.m.
Thank you, everybody.
Thank you.
Thank you, sir.
Get
Thank you, sir.
refreshed a little in the weekend.
Thank you, sir.
Semester is very tough.